Good afternoon, my dear students. Today we are going to see the topic binary arithmetic. So, what is the meaning of this title? That means we are going to do the arithmetic calculations in binary numbers. Okay. So, already you know well, as the decimal numbers, the binary numbers also permit the computations like addition, subtraction, multiplication, and division. These things already we know well, right? The following session only deals with binary addition and subtraction alone. So what are the ways, what are the methods to calculate these kind of binary addition and subtraction? We'll see in this video. Shall we start? Yes. So the first title, binary addition. So this is the tabular format for binary addition. So you have to follow this table format once you do the binary addition calculation in number systems. See the tabular column all of you. Usually we are adding both A and B inputs, like the first input is A, the second input B. So usually we want to add any values means, or if you want to make any addition calculation means, we need at least two values. Is it correct? Yes. So that's why we take both A and B. So A having 0 and B having 0. Now both the values are added. Now 0 plus 0, the answer is 0. So that is the title, sum of A plus B. Okay. And before we have to start this calculation, you just write like this, A and B. These two, A and B is input, and this is the resultant output, that is sum of A plus B, and this is carry. In case in your addition calculations you have any carry numbers, you can put like this column. Okay, so this is a tabular column. You can follow this tabular column for binary additions. Whenever you have to do the binary addition calculation, you have to follow this table. See that 0 plus 0, so the answer is 0 as usual. 0 plus 1, the answer is 1. It is also a usual thing. And 1 plus 0, that is 1. Then finally 1 plus 1 is 10 generally in binary addition. But usually in mathematics 1 plus 1 is 2. Is it correct? But here it is different. 1 plus 1 is 10. So the sum bit is 0. The carry bit is 1. So in the carry bit you can put like here. Okay. So right. So this is a way you can calculate. So that's why I mentioned here in 1 plus 1 is 10. It is nothing but some zeros and the 1 is carry bit. You have to write like this. This carry bit is added with the previous position of the bit pattern. So how can you added this value? This carry bit is added with the previous position of the bit pattern. Okay. So this is the general rule for making the binary addition calculations in number system. Right. Now we are going to discuss about the example. See that. This is a question. What is that? 1011. That is one of the binary number. And another thing 1001. It is also one of the binary number. Why I am telling like these two is a binary number? Why? Because both the numbers, the base value is what? 2. So obviously this is what number? Binary number. Now we are going to make this binary number as an addition process. Okay. Right. See that. First number 1011. I write like this. Then second number 1001. Now we want to make these two numbers for addition purpose. 1 plus 1, that is 10. As per the table calculation, 1 plus 1 is 10. So this 0 is here and this 1 is here. This is a carry bit, right? So use this carry bit to the next calculation pattern. Okay. So 1 plus is 10. 0 is here and 1 is right here. Now usually 1 plus 0, that is 1, right? So this 1 added with this 1. So 1 plus 1, 10. 10 again 0 is here, that is sum bit. The carry bit goes to here. Got it? Now 0 plus 0 is 0. Then in the carry bit having 1. So 0 plus 1 is 1. Right? The next one, 1 plus 1 is 10. So sum bit here. This is the carry bit. Okay, so now the answer is 10100 base 2. Understood? This is the way you can calculate the binary addition process. Understood? So all the top values should be considered as what? Carry bit. All this answer should be considered as sum bit. So always you have to write the sum bit as answer and carry bit for the calculation purpose. Okay, from one bit to the next bit pattern. Understood? All right. And this is another example for binary addition, but here the values are given by like a decimal format. You see that both are decimal number. Why? Because the base value is 10. So these two decimal value, first of all you have to convert binary number, then after that you can make the binary addition calculation, right? See the step number 1. Convert 23 and 12 into what form? First of all, binary form. Okay, so this is the 23 base 10 box and this is the 12 base 10 box. The first thing, using this 23 decimal number, we are going to convert into binary. How is it possible? Okay, first of all, you have to write the 2's power notation. 2's power notation in binary. Already I told, no? What is that? That means the first value, that is what? 2 power 0. The next value is 2 power 1. The next value is 2 power 2. The next value is 2 power 3. The next value is 2 power 4. That's all. Now what is the value? 2 power 0. That is any value to the power of 0. That is what? 1. Okay. The next value 2 to the power of 1. That is what? 2. Then 2 to the power of 2 is nothing but 4. And 2 to the power of 3 is 8. And 2 to the power of 4 is 16. So these are the 2's power method. Okay. And then now we want to check the given number is 23, right? So here, where is the 23 number? It is not possible. We are not getting the number 23 as directly manner. Yes. Then how can you make this number 23 here? You just add the number. Once you get 23, that is a possible value. Okay. So first you have to add the numbers. So what are the numbers you can add for getting 23? First you can take the upper limit value 16 here. Then after that 4, 16 plus 4, 20, 20 plus 2, 22 and 22 plus 1, 23. So what are the power value you have to take? That particular position only you can make 1. The remaining numbers all are 0. So what are the numbers we taken for making the number 23? The first one is 16. The next one is 4. That is 16 plus 4, 20. The next one is 22. The next one is 22 plus 1, 23. So these are the 4 numbers only we taken for making the number 23. So that's why all the position weight, you just mention number like 1, like this. And one number is, I just ignored that. So I just put the value is 0. Okay. So now write the number as usual, 10111. So 10111 they are written. But before that they are adding 3 zeros. Why? What is the reason? Because we are converting the value as 8-bit format. So 8-bit format means already we have a 5-bit option. 5 values are there, 1, 2, 3, 4, 5. Then we, instead of this value, you just add 3 zeros. Now you can convert the 23 value binary number as 8-bit. The same thing you can follow as 12 also. First of all, you just write 12. So 12 means maximum, the value is, we are not getting the value directly as 12 here. So same thing here, that is 2 power 0, then 2 power 1, then 2 power 2, then 2 power 3. Okay, all right. So now as usual, 2 to the power 0 is 1 and 2 and 4 and 8. Now we want to get number 12. Is it any possible to get the value 12 directly? No. So now you just add the value. What are the values you can add for getting number 12? Both 8 and 4. 8 plus 4, 12. Obviously we can get. Yes. So that particular number only you just write 1. The remaining both are what? 0. So you just write 110, that is answer. That is a 4-bit option. But we are going to convert the 8-bit format means before that you just add 4 zeros. Now you just count the value, 8 values are there. So this is the way you can enter the 8-bit format for the given answer. Okay, so both 23 base 10 and 12 base 10 we are identified. Now we just make an addition. This is the format of 23 binary format, and this is the 12 the decimal value of binary format. Okay, now we just add as per the binary addition methodology. So 1 plus 0, that is 1, 1 plus 0, that is 1, 1 plus 1, that is 10, 0 is here and 1 is here. Okay, right? Now 0 plus 1 is 1, then again already some 1 is there on the top, right? So 1 plus 1, 10 again, 0, and put 1 on the top. Now again 1 plus 1, 10, put 0, and again put 1 here. Then here already 0 plus 0, that is 0, but 1 is on the top of the value, that is carry bit. So 1 we have, so we just add 0 plus 1, 1. The remaining part is what? 0. That's all, right? So the answer is what? 1, 0, 0, 0, 1, 1. 1, 0, 0, 0, 1, 1. Base 2. Okay, right? So 12 plus 23 plus 12, that is what? 35. So 35, the value 35, what is the binary format for 35 means? 1 0 0 0 1 1 base 2. Is it okay? That's it. And that's all about this binary addition format. I hope, did you all understand well? Yes. The next one, binary subtraction. It will be slightly different from binary addition. Okay. See here, same set of A and B input, and we are using the word difference. In binary addition, we are using what? Sum. Alright. And here we are going to do that subtraction calculation. So this is nothing but difference. So the formula is A minus B as usual, right? So same thing, 0 minus 0, that is 0. 1 minus 0, that is 1. 1 minus 1, that is 0. This is usual calculation up to this 3. Then last one, 0 minus 1, we can't able to do that. So you can borrow 1 from the nearest one. Okay, you can borrow. After borrow, it should be converted into what? 10. 10 minus 1, the answer is 1. Don't forget, 10 minus 1, the answer is 1. We can't able to calculate 0 minus 1 directly, you just buy the value or borrow the value from the nearest one. So that time it will be converted into 10. 10 minus 1, that is 1. So this is the way you can subtract the value. Okay, yes, fine. See the calculation part here. This is example number 1. See that. So what is the question? 1 0 0 1 0 1 0. That is the first value of binary number. The next value of binary number is 1 0 1 0 0 0. Okay, base 2. So now I just write like this. The first number is 1 0 0 1 0 1 0. 1 0 0 1 0 1 0. The next thing 1 0 1 0 0. Now simply subtract the values. 0 minus 0, that is 0. 1 minus 0, that is 1. 0 minus 1 we can't able to do directly. So you can buy the values from the nearest one. Okay. So nearest to having, we have 1, right? So directly you have to buy from here. So once you value should be passed from here to there means automatically this value is converted into 0. And here this will be converted into 10. This 0 is converted into what? 10. Understood how the value should be changed from 0 to 10? Because we are borrowing some values from the nearest one. So automatically the value should be converted into 10. So 10 minus 1, that is 1. And here 0, 0 minus 0, 0. Then next one, 0 minus 1, we can't be able to do that, the same action. So you can borrow from nearest one. Then here, unfortunately, here also 0 is there. So we can't able to borrow anything. So see the next one. What is that 1? Here 1 is there, right? Now you just converted this 1 into here. Then it will be 10. Then after that you have to buy from here to there. Now it is 10 and this is what? 1. Okay. Here 1 is there. Understood? Right. Now 10 minus 1, that is what? 1. 10 minus 1, that is 1. And here 1 is there already. This 1 is there. So 1 you have to write like this. And here both are 0 because we have borrowed from here to here. Right. So automatically this value is converted into 0. Understood? So the answer is 110, 110 base 2. This is a way you can calculate the binary values. Okay. So if you want to understand completely for this binary subtraction means, you have to do some exercise as per the textbook or as per the inside of the textbook. You just follow the textbook works or exercises. Okay. Right. So this is another way you can subtract the values. So we are given the values as directly as a binary number. So as usual, what we done in the binary addition, same thing you can follow here, binary subtraction. The value is minus 21 and 5. So first you can identify 25 base 10 value. You can find the binary values for this 21. Then after that you can identify the minus 21 values. So what is the method? You can find the negative value for getting the binary numbers using ones and twos complement. Using ones and twos complement, you just apply for the negative decimal number. Clear? So if you want to get the binary number from negative decimal number, you must involve that number into ones and twos complement form. Okay, see that. Now first you can take minus 21 value. Now first you convert the value from negative to positive. It is 1. Sorry, not 1, 21. So now we are going to make that 21 is converted into binary. So here see that as usual, 2 power 0, 2 power 1, 2, 3, 4. So what are the values? Is there any possible to get the 21 values directly? No. So what are the values you can add for getting the value 21? So first one is 16, the next one is 4, 16 plus 4, 20, and 20 plus 1, 21. So this is the method you can identify. So where the numbers are, which number here we can select, that number part only you have to put 1. The remaining all are 0, like this. Okay, so after now we have completed 21, that is number 21 positive value, we can identify the binary numbers. Now we are going to convert it into minus 21 values. So how is it possible? The same rule. So 21, what is answer? This is answer. Now we are going to apply ones and twos complement. So what is the difference between these two, ones and twos complement? Ones complement is nothing but already we discussed. What all the values are inverted by zeros and ones. Inverted by zeros and one means what? Your question number having zeros means everything will be converted into 1. Your question number having 1 means all the values are written by 0. Okay, so that is what inverts. Inverts all the bits. Zeros now it will be converted into ones, and ones all are converted into zeros. So that is what inverts all the bits. Understood? So here, what is the answer of 21? 00010 Now we are going to apply the ones complement action. So wherever 0 is there, everything will be converted into 1. Wherever 1 is there, that is everyone is completely changed by 0. Okay, right. Now see that 21. This is a question. Now we are going to convert one's complement. So 1 should be converted into 0, 0 should be converted into 1, 1 should be converted into 0, like this. The next one, what is the meaning of 2's complement? Adding this value with 1. All the value 111010 is combined or add with 1. So 0 plus 1, that is 1. The remaining all are what? The same number. Understood? Because we are adding only one value, that is 1. You just add with the previous first complement notation. We simply get the answer is 11101011. Okay? Right. The next one you can identify finding the value of 5 base 10. You can identify the decimal value into binary conversions used by repeated division by 2 method. You can use for that. You can convert it into given decimal number into binary, right? So you get the value like this. So after getting the binary format for both the values, that is minus 21 and 5 is right here. Okay, so after finishing this, we are going to add the binary addition calculation for the given number minus 21 base 10 plus 5 base 10. Okay, right, we'll see that. See the next step. So now, see, this is a tabular column for minus 21 base 10 binary format number here and 5 base 10 binary number format here. Now both the values are adding together. 1 plus 1, 10, 0, balance 1 here. Then here already 1 is there, right? So 1 plus 1 again, 10, 0, balance 1 is here. Then again 1 plus 1, 10, 0, balance 1 here. Now 1 plus 1, 10, balance 1 here. Here already 2 zeros only, right? So that 1 plus 0, 1, directly you have to put. The next one, here no 1 is there, all are 0. So on the top, all are 1. So 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, the same number is there. So this is a resultant output for minus 21 and 5 performing the binary addition process. So this is answer. Okay? Yes? Right. So these are the different method to do the calculation for both binary addition and subtraction. The next topic 2.7, representing the characters in memory. So how the characters are representing in computer's memory. In general, totally we have a 26 uppercase letters and 26 lowercase letters and 0 to 9 digits and some of the special characters are used in a computer, which is called as what? Character set. So that is known as what? Character set. So a character set is nothing but it includes alphabets, numbers, and symbols. All these characters are denoted through the numbers only. Why? Because the machine knows only the machine language. That machine language is full and full made up of numbers. That is what? Numbers, binary numbers, right? So all characters in the character set needs a common encoding system. So we are following different types of encoding system here. Number one, BCD, that is binary coded decimal, and number two, EBCDIC, that is extended binary coded decimal interchange code, and number three, ASCII, American Standard Code for Information Interchange. The next one is Unicode. Then final one is ASCII, that is Indian Standard Code for Information Interchange. We'll see one by one what are the coding schemes, what are the different types of coding schemes. See one by one. The first thing is binary coded decimal, that is simply called BCD. This encoding system is not in the practice right now. Why? Because it is 26-bit encoding system. Okay, and it can handle only up to 2 to the power of 6, that is totally 64 characters alone it will be performing. So this is the oldest encoding system format. Okay, just know about this information. Okay, right. The next one, American Standard Code for Information Exchange, we are simply called ASCII. So these information already we discussed in the previous lessons, right? And also this lesson also. And this is the most popular encoding system recognized by United States. So most of the computers are use this system only nowadays. Remember, this encoding system can handle English characters only, not for any other language. Understood? So this can handle up to 2 to the power of 7. That means 128 characters will be supported. In this system, each character has individual number. Okay. The new edition or version of ASCII is 8. It has 28 bits and it can handle how many characters? 256 characters. Okay, it is a represented from 0 to 255 unique numbers. So in the 2 to the power of 7 bit, maximum calculation of character is what? 128. But this 28 bits, that is what? It's not a 28 bits, 208, 2 to the power of 8 bits. Okay, it is an error format. See that? I just mentioned here. You just change the value. This is not a 28 bits. This is what? 2 to the power of 8 bits. 2 to the power of 8 bits can handle this 28. You have to write like this, 2 to the power of 8. Some printing mistake is there. 2 to the power of 8 bits can handle 256 characters. So starting value is 0, ending value is 255. So totally 256 unique numbers. The next point, the ASCII code equivalent to the uppercase letter A is what? 65. So each alphabet we can allocate this ASCII code. Okay. And the next, the binary representation of ASCII, it is nothing but a 7-bit value. Okay. The binary representation of ASCII is what? It's a 7-bit value. You just write like this. So this is a ASCII value for 65. Okay. Right. And this is 8-bit. If you want to enter in the sense, you just write like bit format. Already we know well, right? 7-bit means the 7 digits are entered by the binary format. 8-bit means 8 digits binary format you can write. So this is the different options we have in ASCII code. The next one, EBCDIC, that means extended binary coded decimal interchange code. That is the expansion of what? EBCDIC. This is very similar to ASCII code with 8-bit representation. Why? Because this coding system is formulated by International Business Machine. That is, the company name is what? IBM. It is one of the very big corporate company. This coding system is formulated by the IBM, and this system can handle how much characters? 256. So the total bit is what? 2 to the power of 8. Okay. The input code in ASCII can be converted into EBCDIC system and vice versa. It is a option they can follow in. The next thing, Indian Standard Code for Information Interchange. That is what? ASCII. This is the system for handling the characters of Indian local language. In Indian, we have a different types of language. So all the language we can use for this ASCII, this as a 8-bit coding system, and it can handle 256 characters, same thing. Okay, this system is formulated by the Department of Electronics in India in the year 1986 to 1888 and recognized by the Bureau of Indian Standards, that is BIS. Okay, right. Now this coding system is integrated with Unicode. So this coding system only now we are integrated with what? Unicode. Unicode is nothing but universal code. Okay. So this is about information about what? Unicode. This coding system is used in most of the modern computers. The popular coding scheme for after ASCII is Unicode because it can represent only 256 characters. Therefore, English and European languages alone can be handled by ASCII values. Okay, and particularly there was a situation when the languages like Tamil, Malayalam, Kannadam, Telugu could not be represented by ASCII. Hence, the Unicode was generated to handle all the coding system for universal languages. So you must follow the instructions through universal language like English like that. Okay, so this is the 16-bit code and can handle 65,536 characters. It is a big one, 65,536 characters. And this scheme is denoted by what number? Hexadecimal number. Is it okay? Are you understand? If you have any problem or regarding about this topic, you just go through it in your textbook from the page number 25 and 25 alone. That's all. Okay. Right. So this is the alphabets, and these are the decimal numbers, and these are the binary number format, 8-bit format especially. These are the octal numbers, and these are the hexadecimal numbers. So each and every alphabet have individual decimal number or binary number is having. You just convert these values or use these values. So alphabet A, that is the alphabet number. So alphabet A, this A should be considered as a decimal number is 65. So this is one of the ASCII code already we told, right? So 65, like capital letter B is what 66, like that you can write like this. Understood? And this side, this is the binary number 8-bit format. The value should be situated or used in a 8-bit format. Okay, so this is the continuation of that one, and it consists of 0 to 9 alphabets. Sorry, 0 to 9 numbers. Here, what is the decimal number for 0? That is what? 48. So all these decimal numbers are considered as what? ASCII code. And this is the binary number format, and this is octal number, and this is what? Hexadecimal number for the relevant inputs. So these are the different methods you can follow for given number to decimal or binary or whatever it is. And these are the special characters. We have some ASCII code. You just see that these are the special symbols: blank, exclamation, double quotes. So what are the decimal numbers for this one? So once you see this, easily you can understand. Understood? So these are the different types of coding options and also numerical value for the given values. Okay. Yes, that's it, and that's all for this lesson, number system. Okay, if you have any doubts, you have to ask me by personally, and in book inside having so many exercises regarding about the number conversions. Okay, so yeah, all the people you can make some assignment regarding about the sums. So you just take a paper and write the sums and send it to your class teachers or subject teachers regarding about that. Okay, see you in the next class. Bye bye.